Well, first of all, thank you everyone. For this, I'm not quite sure if you guys are already familiar with Cassandra, and if I do make any terrible mistake, please point it out, because I don't want to keep continuing with my rubbish. All right. So this is going to be the agenda for the evening. So we're going to have two parts, and we're going to have a little break in the in between parts 1 and 2. Reason being, first, I need a break. I can't keep talking, and secondly, you guys can go and have a drink or something, and also have a break. You may fall asleep, you may want to wake up, and all that. So yeah, let's try and take a break when we hit half of this topic, which is the first part is going to be a bit more theoretical. You have to understand, well, the focus is going to be what Cassandra is all about, and the second part is going to be more on how to actually use it. So the first one is what it is, and second is how to actually use it. On the first part, obviously, I'm going to be a salesman. I'm going to tell you all the merits of Cassandra and tell you where it shines. And on the second part, I'm going to tell you, as I walk you through various, well, towards the end, I'm going to tell you where it actually is doing a terrible job. So then I'm going to be a critic. That's the yin-yang thing, right? So here are some resources. If you're new to it, or if you're already familiar with it, you probably know all these things. The number one resource is planetcassandra.org, where you can actually get input from the open source and the paid community. Cassandra is actually primarily built and maintained by DataStax. DataStax contributes to about 80 to 85% of the code that goes into open source Apache Cassandra, and they have obviously made a community edition and an enterprise edition, with enterprise edition being supported variant with more features. And obviously there's the open source project where you can go and download stuff. Right. Before we get started, I also would like to say that I have a USB stick. I know it's quite old-fashioned, my excuses for it, but in this USB stick you would find the installer for pretty much all the operating systems, both the open source and the enterprise edition. And the nice thing about the enterprise edition is you can actually use it until UAT, and only when you actually go to production you have to start paying DataStax. So it's quite neat if you want to actually try and use it. Nobody's going to stop you. It's perfectly legal. And I also have all the docs, the drivers, the additional tools, the slides, ebooks, and a VM. If you don't want to install all these software and waste time with it, you can just start the VM on a virtual box, and voila, you have all the tools right there for you. You can just play around with it. Okay, well, that being said, during the break we have some goodies over here. Some screen wipes, some stickers, some t-shirts of various sizes, so please feel free to pick one. I guess that's it. That concludes the initial talk, and now we can get to business, right? So now let's talk what this whole big data is all about. Well, when you say big data, you pretty much see all these words, and you have different families of big data products, right? And well, Cassandra actually falls in here in the database family, right? It's one of the databases that is that falls into the big data categorization. The funny thing is, everybody talks about big data. They have been talking about big data for at least the last 2 years, and if you actually go and speak with some of the managers out there, or some of the companies that are actually implementing big data or doing it, they have no clue what it is. They just think, oh, we buy a product off the shelf and that's it, we're done. Just like business intelligence, right? But no, that's not the case, because with big data we actually, well, what actually it is, here comes the formal definition. We're talking about data which is really massive in terms of volume, and it's coming at a very high velocity, and it's varied in terms of data sources and formats, which means it's structured, unstructured, and semi-structured. What is structured? You can think of your relational database. Everything is nicely sliced and diced into tables, rows and columns. Unstructured is it could be something like a blob, or streaming data, or it can also be semi-structured, like your tweets or your Facebook wall update, wall posts. So it does have a structure, but it's not strictly structured, And then, well, veracity. The veracity bit is where you have some data flowing in. For example, there's a weather station about half a kilometer from here, which collects all the data. You do get these data at a very high velocity from all these weather stations. Some of them actually give you data every second or every millisecond or something like that. And then, well, obviously, if you're going to get it every second or millisecond, it's going to be a lot of data. But some of the times, the data is not really accurate. So, yeah, is the data actually correct or not? That's the fourth bit. So when you're dealing with all these four, you're actually talking big data. Now, that was the definition. And now, why big data is important? Yeah, I'm not going to go through this. You'll get a slide. You can look it up later. Yeah, so, well, this is the big data stats for Twitter every 60 seconds. Well, I'm not going to read through this, but you get the idea. So you really need data that is available across multiple regions, very fast and reliable, and there shouldn't be any single point of failure. So with these concerns in mind, your traditional relational model cannot fit the needs. Why? Because you have something called the joint pain. It's not because we all get old and we start to have joint pains. Well, that'll also happen unless you're really fit. It's just a matter of when, not if. As the data grows in size, in production data, and if you're going to go join across several tables in order to actually make a query, the performance will start to deteriorate. And that's the joint pain that we're talking about. And these all happens because we are trying to have normalized schema, and big data avoids all this sharding and hopping from one table to another and having normalization, denormalization, and all that bollocks. No, we're not going to do any of that. What they do is they have a completely rethought model to actually fit these business needs. So they say, well, we cannot have everything, so we're going to sacrifice the ones on the left for the ones in the right. Again, I'm just going to skip through it, because if I do talk about it, it's going to take too much time. You can only choose two among the three. This is called the CAP theorem. You can look it up on Wikipedia. So you have consistency, availability, and partition tolerance. You cannot have all three. You can't have everything in life. So pick two, and then you choose which database really fits your needs. Well, it's a bit color-coded because, well, as you can see, the one in red is RDBMS. RDBMS is very high in terms of consistency. It is ACID, right? Everybody over here knows what ACID is. And, well, obviously on the other side, on the extreme other corner, you see, well, the green bit here is Cassandra. This is what we are going to talk about. Cassandra is not going to assure you that the data that goes in is always consistent at all times. So that's the bit you're going to lose. We're going to go and talk a bit more about that. So when this whole big data thing started to become quite popular, I do remember about in 2010, 2011, Larry Ellison introduced this Exadata. He said, buy a bigger machine, give us more money, and we'll solve all your problems. And, well, no, it doesn't solve all the problems. It just solves Oracle's problems of making more money. So that's where Cassandra came into play. It's like this, right? You have a big cart, right? And if you want to pull the big cart, you're not going to breed a bigger horse that is stronger. No, at some point you want to put 2 or 3 horses that pulls the cart. You can't breed a bigger horse. So with that kind of thoughts in mind, Cassandra started to emerge as a distributed database among which is hosted on community hardware, which means you don't have to buy special hardware to run Cassandra. And it's linearly scalable, which means as the data grows, your performance is not going to deteriorate, and there is no single point of failure. This is another buzz term within Cassandra. They say masterless ring architecture. So there is no concept of master slave. There's nothing that actually does these what is it called? Housekeeping or anything of that sort. So what happens is, let's say a client writes normally in Cassandra, when you write something, it gets automatically replicated. The default replication factor is 3. This is out of the box. So if you have a cluster with 3 nodes, this is what they also recommend. Your data gets replicated across 3 nodes. So you write to 1 node, and the data gets replicated to 3 nodes. So there you go, you have fault tolerance. If 1 node goes down, you still have the other 2 nodes to get the data from. Secondly, this is the linear scalability bit, where you have, if the number of transactions per second increases, all that you have to do is throw in more servers. That's it, problem solved. It's as easy. It really is that easy. So simply add nodes to increase the performance and capacity. And here is another bit. This is the multi-data center support, which means, let's say you have 2 data centers, one in Europe, another one in North America. And what happens is that you start to write data to 1 node within 1 data center. It gets replicated within the first data center, and then it gets asynchronously replicated to the other data center, where it also gets replicated. So this is a real use case. What happened is that, I'll tell you why, because with Netflix had a data center in New York State, and there was a hurricane that actually sank the data center. They were brilliant because they were thinking, well, we have to cool these data centers because the room's really getting hot. So what we do is we just get cold water from the sea and then cool this whole data center. That way we don't have to pay a lot for the electric company. But then there was a hurricane and the whole data center got flooded and they lost data. Sorry, I should have done this myself. And, well, the other data center was still up and running. That's it, no problem. So now we're not talking about disaster recovery. The focus goes to disaster prevention. Now, Netflix, obviously our friends, came up with another series of a family of products. I've actually used this one called Chaos Monkey. Netflix puts all their data into Amazon's AWS, Elastic Cloud infrastructure. So what they do with Chaos Monkey is it picks 1 node at random, and then it brings it down and see what is the performance. And then as you can see, like Chaos Monkey, you have Gorilla Monkey, Kong Monkey, which brings down the data center or the entire availability zone and still checks, hey, is our website still suffering in performance or is doing a good job?